I'm Dr. Ben Newman. This is Ask Dr. Ben. I'm a coronavirologist, and I'm going to try to answer your questions using the stuff I've read in many, many scientific papers, or at least the figures of the papers. Yeah, don't always read all the words. Let's see. Next question is from Kay. How are you doing, Kay? So the question is, I've heard that some of the new variants, these viruses, may be more contagious. That appears to be the case, but this is a thing that is easier to say than to demonstrate in a way that a careful scientist would believe you. Yeah, it seems totally reasonable, but it's a tough it's a tough experiment to do. So question is, how are they more contagious? Are they able to infect people differently than the original viruses that the vaccines have targeted? Good question. Yeah. So, what do we know so far? We know that, as far as we're aware, the new variants are still entering using the same receptors. So it's going to be the ACE2 protein as the thing that the virus holds onto, kind of clamps onto, and then that gets it close to the cell, and then it's waiting for activation. And we know there are several different proteins that can activate it, and so far I don't believe we've seen much change at the site where the activation would be, which is it's called Tempress2 is one of the enzymes, or different kinds of cathepsin cleavage site. They both cut at the same spot, and I haven't really seen any change there. There is a bit of change in some of the strains around the furin cleavage site. Now, that's not something that you need for the virus to actually enter, but it's something that gives the virus a little boost. It basically puts a cut somewhere nearby, loosens up some of the pieces so that they can fall apart a little faster when they need to fall apart, once it's found the right receptor. So basically, the virus looks as though it is doing the same thing. It's just doing it a little more efficiently. Now, there are many ways that you could end up with a virus that's more infectious. One of those would be to just produce more viruses per infected individual. And that seems to be what some of these variants are doing. So the B117 UK variant, although, yeah, I don't know, it's kind of silly to call it the UK variant, but whatever. That thing does seem to grow to higher titers, like higher amounts inside of an infected person. So there was a nice paper in the British Medical Journal about 2-3 days ago that also showed that that particular strain, in addition to a couple other papers which showed that it grows more, it also seems to have more severe symptoms that are associated with it, and a higher risk of death. It's not enormously higher. It's about 60% higher, and you'd say, whoa, 60%, but 60% on top of 1.5 to 2%. Yeah, so it's like a 3% deadly virus-ish. Yeah, so bad, certainly not good, but yeah, not the end of the world either. Just a thing worth watching and worth driving to extinction through vaccination. Very, very much, yeah. Let's see. But there are questions that I don't think are answered. So, in order for the immune system to see this virus and respond to it, the immune system has to be able to cut it in certain places, has to be able to lock on to certain parts of it, and has to be able to show it to other cells in the immune system. Then those other cells will change what they're doing until they can get a good grip on it. And then once they've figured out how to get a good grip on a little piece of the protein, they can then go out and try to find that little piece in the context of an actual infected cell or a little virus that's got loose somewhere, and hunt it down and destroy it. So you could have differences that change the way the immune system recognized this, and that would be like a different set of experiments than most people are doing to actually detect something like that. But it's a way that the virus could change. The virus could stick more tightly and just to the cell. That's a possible way. But in the past, we've had viruses that are both more stable, that had an advantage. So that's the D614G. And we've had viruses that are less stable, which are some of the furin cleavage mutants. There are a couple called the robin and I forget the other bird pelican. There we go. Robin and pelican variants, and I really like those names. Yeah. And those have mutations, if I'm remembering correctly, around the furin cleavage site, which would make them a little more easily activatable. And once they're activated in this way, they become kind of looser, floppier. But really only after they've got close to a cell in the lung. So I think they want to be real tight and firmly packed at first, and then really loose when it's time to actually go and infect the cell, and it's kind of a dance there. So yeah, you've got mutations that do opposite things that both can make a better effect. So other than that, we really don't know for sure what this one is doing, but with some of the other strains, when they have come along and people have tested them, you can actually throw different strains into the same flask of cells, and you can let them compete. And the one that is better at any stage of its life cycle will actually spread further and faster than the other one. If you do this, take the winners off of that one and put them onto another one, over 3 or 4 of these, what we call passages, you can end up driving one virus to extinction, and you get an entire set of the other virus. So that's something that has been done for a few of the variants, but not for all the rest of the variants. And so we don't really know there. But that would be a good way to at least look at, is this something that we would be able to measure in a little petri dish full of cells? Or is this something where we're going to have to be able to measure it inside of like an animal with an immune system? Yeah, that's the question right now. And so not only do we not know the answer, it is not entirely clear which experiment is going to show the answer, but there are some leads that I think need to be done, and I think those will get us closer. So yeah, there you go. That's the longest non-answer. I don't know if it's the longest non-answer I've ever given. I've given a few long ones, but yeah, that's as far as I can tell where we are right now. So thanks very much. This was Ask Dr. Ben. Thanks for a good question.